Just a second. Okay, we are fine. I think there's some connectivity issue. Okay, so the problem that we are discussing today is merge two binary search trees. So understand this question, it's an important question, but not that hard as they have labeled it. Okay, so you are given two binary search trees. Let me just write them, and meanwhile just again check if we are live. Okay, cool. Let me take this example and now let's head over with the question. I just want to ensure everything is in place because... Okay, guys, just let me know in chat if you face any issue in connectivity. Okay, let's start. So we have two binary search trees. Let's take the example. One is 5, 3, 6, 2 and 4, right? So the other one that we have here is 2, 1, 3, 7 and 6. So I'm sure you must have already done the question. We ourselves have solved this problem of merging two sorted arrays, merging two linked lists in place. We know that all. Now here the question is that we are given two BSTs and we have to merge them in such a way that the new tree that we get is also a binary search tree. Now you might be wondering, what we can do is that we go to each node, compare them, and then we see that where to, for example, if I have 2 here, one thing is for sure that 2 should go to the left of this 5, but comparing each node and then forming a BST from there is not going to give us an optimal solution. So what can we possibly do? So one observation that we used in the previous lecture is that we are going to make use of this property that a binary search tree in order traversal of a BST gives us the nodes in the sorted order, right? We already saw this thing in the previous lecture. So just let's do that. In order traversal of this tree, let's see what we get from here. In order is left, root and right? Fine. So let's do that and write the nodes in order traversal for both the trees. What I get from here is left 2, root, right. This covers the left part, root and right. So what you see here is that I've gotten all the nodes from BST from first tree in the sorted order, right? Let's do the same traversal on second tree. So what I'll get is left, then root, then right subtree, and in the right subtree I'll go to the leftmost node, which is 6, then I'll go to the root node 7. Okay, there is no right, so this left part of 3, it was null. One second, I missed one thing. Writing this again. Going to the left node 1, then the root node, which is 2, and then in the right subtree I'll go, this is the right subtree, right, going to its left node. There was no left of 3. Okay, then I end up writing the root value, and then I'll go to its right part, right? In its right part, the leftmost node is 6, then I'll go to the root 7. There is no right, nothing else to write here. If you see 1, 2, 3, 6, 7, this itself is in sorted order. So once I do the in order traversal of both the binary search trees, one thing is sure that I'm going to get the nodes in their respective sorted order, correct? Now my task is what? See, the question is not too difficult. Why I'm saying so? The question would have been actually harder if they've asked you to construct a binary search tree from the nodes you got from both the BSTs. What I mean by that, if you see, just a second, this is the function that you have to complete. What are they expecting? They're expecting you to just return the nodes in the order of it, in such an order that when you merge both the trees, in whatever order you'll get the nodes, that's what you have to return in this. If you see given two BSTs, return elements of both BSTs in sorted form. So already we have, right? So you have to return the list in the sorted order of all the nodes that you will get in the final BSTs. So actually this would have been harder if they had asked you to return the root node of that probably tree that you will get from all the nodes once combined together in the sorted order. You getting my point? Here you do not have to construct the tree, you'll just have to actually return the sorted elements of including all the elements from the trees. So basically the question comes down to sorting two lists or arrays. Not sorting, merge two sorted arrays. This is what your question comes down to. Merge two sorted arrays and you just have to return that array list. Merge two sorted lists, array lists. That's the question. This is the reason. Now only the trick part was, if you have done enough exercise on BSTs, then you would know that in order traversal gives you the nodes in the sorted order. And once I have the nodes in the sorted order, my task comes down to, I have to merge two sorted lists, and we know how to do this in place. What do you do in place? You iterate till the length of this array list. So okay, we'll take two array lists here. Okay, I'll take two array lists here to store the nodes in the, after traversing the nodes I'll be storing will be in the array list. Now till the length of this array list and other iteration till the length of this array list, one by one I'll just compare 2 and 1. 1 is less than, so I'll create a new array list which will be storing the final, which will be merging the two sorted arrays. So 1 will come here and then there will be 2 pointers. This is in place. I am just reiterating it so that you can recall how do we merge two sorted lists. Not that I'm going to do this again. You can go and watch the video. And obviously that sorting in place reduces our time complexity, but this somehow this solution that I'll show you, they're accepting it in bigger means in a larger time complexity as well. So I've simply used collections.sort, but I'll not encourage you to do that. That is why I'm explaining you again this in place sorting method. So because this is entirely about this question, nothing more to it. So what do I have here is I'll have 2 pointers, I, j. The smaller one I'll insert in the new array and move that pointer. So j comes here. Now I'll compare these. Okay, so let's say I take ith one, I move my next pointer here, compare them. The jth is smaller one, so I'll write it here, copy it in the other array, and j pointer moves ahead. Let's say I take the ith one and move my ith pointer to the next one, which is a smaller one, the one at jth pointer. So I'll take 3 here, move my j to the next pointer. I is smaller one, so I take 4 here, move my I to the next pointer. Once one of them reaches the end of the array, one of the array, let's say one of the iterations is completed, then you must be remembering this thing. We take another while loop that iterates over the other array until it reaches the end of the array, and we simply copy the remaining elements into our third array, which is this. Okay, so I and j, 5 is smaller, I moves forward. Now compare, let's take the ith one, and I reaches the end of the array. Now we are left with 2 elements in this array, so I'll iterate over this array while it reaches the end of, j reaches the end of this array, and simply copy the remaining elements into this. So you see what I get is 1 2 2 3 3 4 5 6 6 7. That is the entire question. Let's see if that was what they expected us to. 1 2 2 3 3 4 5 6 6 7, right? So that's all about this question. I hope you understood this. Again, I'm saying in the solution, just because it gets a little smaller, I'll not encourage you to do that. Use collections.sort. Reason being, it will take n log n of, actually m plus n log m plus n in time complexity, whereas this in place will take big O of m plus n. So overall time complexity of this approach will be big O of m plus n. Obviously we will be using an in order function which will be traversing through each tree in the in order way, and in an array list which I'll be passing it in this in order function, they will be storing the traversals, the nodes in the in order traversal into this array list. So that in order traversal is also going to take big O of n time complexity, big O of m time complexity for the other tree, right? So let me just move to this code and show you. I'll just check if you guys have any doubts so far. Okay, so let me just write it. So in your merge function, what are we going to do? Give me a second. I got my screen back. Fine. Let's start off. So I am creating two array lists, so which will be storing the in order traversal of both the trees. So it will be of type integer. Here are one new array list. Fine. Other one will be a2, let's say. Okay, then I will be creating a new function. Let me just create it. Public void in order. Okay, in order, which will be taking node root 1 and the other one will be node root 2 node. At a time only one node I'll be passing, and the array list. Fine. Array list of integer ARR. Cool. Okay, now what? Let's complete this function. Very simple recursive approach. If root is not null, or you can write if root is null, return, just return from there. If root is not equal to null, make a call to this function for the left subtree. Root dot left, pass your array, right? When you are at the root node, that's when we are going to add it to your array. Okay, so arr dot add root dot data, correct? And in the other traversal, you make a recursive call to the right subtree, right? Arr. Fine. Cool. Okay, this is done. Now we make a call to this in order function by passing root 1 first of all, and its array a1. So array 1 will be filled with the in order traversal of the BST1, which will be in the sorted order. We know that. Same thing for the other BST a2, correct? So a2 will be there filled with the sorted order of the other BST. Now here, as I told you, for the sake of smaller code, I am just first of all the other new array list again, there's no fixed size to it. So what I'm going to do is, for int I belonging to a2, let's say, I am going to add in a1 all the elements of a2. So basically in this array now I am inserting all the elements of a2, so that in a1 I'll have all the elements of bst1 and bst2. Okay, so a1 dot add I. Okay, now I'll do just collections dot sort in a1 on a1, collections dot sort a1, and return this array list, which will be the sorted order of combined two BSTs when merged. Okay, let's check. a1 dot add. So that's all about this problem, guys. Hello guys. If you have any doubts, let me know. Else we are done with this question. Coming on to the time complexity, as you can see what we have done here. We have written an extra in order function which is taking big O of n time which is taking the how many nodes are there in any first BST. If let's say n, so big O of n for that, big O of m for that. Then this all together here in this approach is going to take m plus n log m plus n time complexity. So predominantly it will be that, but I've already told you and you already know how to merge two sorted arrays in place. So that is going to take big O of m plus n time complexity, right? So that is all about this question. If there are no doubts, I'll just wrap it up. Fine. Okay. So that's all for today, everyone. See you all in the next lecture tomorrow. Bye.